Welcome to this video. Today, we will familiarize ourselves with trigonometry, which is an important branch of mathematics. Let us now discuss some situations. Raju is flying a kite in a field near his house. Can you tell how high the kite is from the ground? Sangeeta and her friends want to know the height of the mountain before climbing the mountain. Can they do that? Standing on the banks of the river, Meena is watching the crows sitting on the electric wire on the other side of the river. Can you find the distance between the crow and Meena? In many such situations, we find ourselves unable to find the height and distance. But it is not that these heights or distances cannot be found. These can be found with the help of a mathematical technique which is a branch of mathematics called trigonometry. The word trigonometry originated from the three Greek words tri, gon and metron, in which tri means three, gon means side, and metron means measure. In fact, in trigonometry, we study the relation between the sides and angles of a triangle. Let us now consider this right-angle triangle, in which angle B is right angle and angle A and angle C are acute angles. Which side is hypotenuse in this triangle? We know that in a right-angle triangle, the opposite side of the right angle is hypotenuse. In the same way, can you tell the opposite side and the adjacent side of the angle C? Well done! If the opposite side is AB and the adjacent side is BC, then can we say that with respect to angle C, the hypotenuse is AC, the opposite side is AB, and the adjacent side is CB. So, in this video, we will understand and learn the relationship between the sides and angles of a right-angle triangle. How many ratios can be found if you calculate different combinations of ratios between the three sides of a triangle? Let's see. Now, if we write the ratio between the given sides, then we get these 6 ratios. Now, if we study the obtained ratios with respect to the angle C, we get these 6 trigonometric ratios, which we call sine of angle C, cosine of angle C, tangent of angle C, cosecant of angle C, secant of angle C, and cotangent of angle C respectively. And in short forms, we show these with sine C, cos C, tan C, cosec C, sec C, and cot C. These are known as trigonometric ratios of angle C. In an easier way, you can remember these trigonometric ratios like SOH, CAH, TOA, which we can write like this, wherein SOH, S means sine, O means opposite side, and H means hypotenuse. That is, the sine of any angle is the ratio of its opposite side to the hypotenuse. In CAH, C means cos, A means adjacent side, and H means hypotenuse. And in TOA, T means tan, O means opposite side, and A means adjacent side. With the help of these three trigonometric ratios, you can also find the values of cosec, sec and cot. Here, cosec is the inverse of the sine, that is, the ratio of the hypotenuse and the opposite side. Similarly, sec is the inverse of cos and cot is the inverse of tan. Can you now write trigonometric ratios for angle A? Yes, the trigonometric ratios with respect to angle A will be as follows. You can see here that the opposite and adjacent sides change for angle A and angle C. If the names of the angles were not written with them, then it would be difficult to understand which ratio is written for which angle. Can you find all trigonometric ratios for angle phi in triangle PQR? Try to solve the question. We will discuss it in the next video. Today in this video, we introduced trigonometry and also we understood and learned trigonometric ratios. In the next video, we will see interesting examples based on this. Welcome to this video. In the previous video, we learned and understood trigonometry and trigonometric ratios. Today, we will see examples based on these. In the previous video, we left a question without solving for your practice. Let us discuss that question. We know that to find all trigonometric ratios, we need to know the three sides of a triangle. Can you tell the measurement of the third side of this triangle? Perfect! For this, we can use Pythagoras theorem. From this, we get the length of PQ, 12 centimeters. Now, we can find the trigonometric ratios for phi. Can you tell me what those ratios are? Well done! These are sine, cos, tan, cosec, sec and cot. In the previous video, we learned that the ratio between the opposite side of the angle and the hypotenuse is the sine of that angle. Can you tell the opposite side, the adjacent side and the hypotenuse for the angle phi in the triangle PQR? Very good! The side in front of right angle is hypotenuse PQ. The side in front of angle phi is opposite side QR and the remaining side PQ is the adjacent side. So, by substituting the values of the opposite side and the hypotenuse, we get sine phi equals to 5 upon 13. Similarly, we know that the cos phi is equal to the ratio of adjacent side to the hypotenuse, from which we get 12 upon 13. Tan phi will be equal to the ratio of opposite side to the adjacent side. Also, we learned that cosec, sec and cot are the reciprocal of sine, cos and tan. In this way, we write all the trigonometric ratios for the angle phi in the triangle PQR. Now, Raj and Sonam draw one triangle each, similar to this triangle PQR. In addition, they also write trigonometric ratios for the angle phi in their respective triangles. And find that the value of trigonometric ratios for the angle phi in all three triangles is the same. Based on this activity, we can say that in a right angle triangle, if the acute angle remains the same, then the trigonometric ratios of that angle do not change with the lengths of the sides of the triangle. In this video, we saw some examples based on trigonometric ratios and got to know that trigonometric ratios for an angle remain the same even if there is a change in the length of the sides of the triangle. In the next video, we will see what can be common mistakes while solving these types of questions. Welcome to this video. In the previous video, we saw the examples based on the trigonometric ratios. In this video, we will highlight some misconceptions related to these. If tan theta is equal to 24/10, then which of the following will be the value of sin theta? Pause the video and try yourself and then match your answer. In the question, we are given tan theta equals to 24/10 and the value of sin theta is asked. Can you tell what we need to do first? Perfect! We know that trigonometric ratios represent the ratios of two sides of a right angle triangle. So first, we draw a right angle triangle called PQR, in which angle Q is right angle and angle R is theta. We know that the trigonometric ratio tan of the angle theta is equal to the ratio of opposite side to the adjacent side of the angle. In this triangle PQR, PQ is the opposite side and RQ is the adjacent side of the angle, which we can also write in this way, where x is a positive number. Can we now find the value of sin theta? Absolutely not. To find the value of sin theta, we will also need to measure the hypotenuse of the right angle triangle, that is, the side RP. We can calculate the value of side RP with the help of Pythagoras theorem, which is 26x units. We know that the value of sine of the angle is equal to the ratio of opposite side of the angle to the hypotenuse of the triangle, which gives us PQ upon RP. Putting the value of PQ and RP, we get sin theta equals to 24/26. So, we can say that option 3 is the correct answer. If you chose option 1, then it is a good try, but this is the wrong answer. From the beginning of the solution till you calculated the hypotenuse, you did the process correctly. But to calculate sin theta, you used adjacent side instead of the opposite side, which caused your answer to be incorrect. If you chose option 2, then it is a good try, but this is also the wrong answer. This happened because in the value given in the question, you have written tan theta as sin theta upon cos theta and compared the two sides, and you got the value of the sin theta as 24, which is wrong. Hopefully, you will have a good understanding of trigonometric ratios and their use. At the same time, it must also have been understood what things are to be kept in mind while solving questions based on this. Welcome to this video. In our previous video, we studied trigonometric ratios. Today, in this video, we will study trigonometric ratios of some specific angles. Raj has right-angled triangle and Simran has equilateral triangle, whose acute angles they have to find the trigonometric ratios of. So can you tell how Raj and Simran will find them? Let us first learn about trigonometric ratios of 45-degree angle. Raj has a right-angled triangle LMN, where the value of the angle L is 45 degrees. The length A of the adjacent side LM is known to us. Find all trigonometric ratios of 45-degree angles. We need to measure all the sides of a triangle. Let's see. We know that the sum of the three angles of a triangle is 180 degrees. Therefore, the value of the remaining angle N of the triangle LMN will be 45 degrees. That is, the value of angle L and angle N are equal. Hence, we can say that the sides LM and MN are of equal length. That is, it is an isosceles triangle. So tell, what will be the length of the side LN? Perfect. For this, here we use the Pythagoras theorem, which gives the measure of side LN is a square root 2. In this triangle, the values of both angles L and N are 45 degrees. So, here we discuss the trigonometric ratios for angle L. In the triangle LMN, the side opposite to right angle is the hypotenuse Ln, and the opposite side of the angle L is Mn, and the adjacent side is Lm. Let's talk about sine L, that is, sine 45 degrees. As we saw in the previous video, the sine value for an angle theta is equal to the ratio of the opposite side to the hypotenuse. That is, the value of sine 45 degrees will be equal to the ratio of the side opposite to angle L and the hypotenuse in the triangle LMN, where the length of the opposite side is A and the hypotenuse is a square root 2. On solving this, the value of sine 45 degrees is obtained as 1 upon square root 2. So, can you tell me what will be the value of cos 45 degrees? Absolutely right. For this, find the ratio of the adjacent side and hypotenuse of angle L. On solving this, the value of cos 45 degrees is also given as 1 upon square root 2. Note that the values of sine 45 degrees and cos 45 degrees are the same. That is, we can say that their inverse values of cosec and sec 45 degrees will also be the same. Similarly, if we talk about tan 45 degrees, then we know that tan theta is equal to sin theta upon cos theta. And the values of sin 45 degrees and cos 45 degree are the same, whose ratio will give a value of tan 45 degrees is 1. Therefore, we can say that its inverse, that is, the value of cot 45 degrees, will also be obtained as 1. Let us show trigonometric ratios of 45-degree angles in a table. Today in this video, we calculated trigonometric ratios of 45-degree angles. In the next video, we will see how Simran will find trigonometric ratios of 30 degrees and 60 degrees angles. Welcome to this video. In our previous video, we saw how Raj had found trigonometric ratios of 45-degree angles with the help of the right-angled triangle. Today, we will calculate the values of trigonometric ratios of 30 degrees and 60 degrees from the equilateral triangle LMN with Simran. Given that the length of each side of the equilateral triangle LMN is 2a and each angle is 60 degrees, from the vertex L of the triangle, draw a perpendicular LO on its opposite side MN, where perpendicular LO is the bisector of angle L and the point O is the midpoint of the side MN. From this, we get two congruent right-angled triangles, LOM and LON here. Let's discuss one of these two triangles, the triangle LOM. In triangle LOM, we see that the angle O is a right angle. Angle L is 30 degrees and M is 60 degrees, where the measure of side OM is A and the measure of side LM is 2A. So, can you tell me what is the length of side LO? Absolutely right. Using the Pythagoras theorem in the triangle LOM, the length of side LO, that is perpendicular, is equal to a square root of 3. So, let's first know about trigonometric ratios of 30-degree angles. The value of the sine 30 degrees from the right-angled triangle LOM will be equal to the ratio of opposite side of the angle L and hypotenuse. On solving this, we get the value of sine 30 degrees as 1 upon 2. So, can you tell me what will be the value of cos 30 degrees? Well done! Find the ratio of the adjacent sides of the angle L and hypotenuse, which when solved, obtain the square root of 3 upon 2. Similarly, we obtain the value of trigonometric ratios tan, cosec, sec and cot 30 degrees. So, in this way, we have obtained all trigonometric ratios of 30-degree angles. Since we also have to know trigonometric ratios of 60-degree angles, therefore, from the above right-angle triangle LOM, we can tell that the value of sine 60 degrees will be equal to the ratio of the opposite side of the angle M and the hypotenuse. On solving this, we obtain the value of sine 60 degrees is the square root of 3 upon 2. And if we talk about the value of 60 degrees, then this angle will be equal to the ratio of the adjacent side of the angle M and hypotenuse. On solving this, we obtain the value of cos 60 degrees as 1 upon 2. Similarly, we obtain the value of trigonometric ratios tan, cosec, sec and cot 60 degrees. Which are represented by the following table. Today, in this video, we obtained the trigonometric ratios of 30-degree and 60-degree angles. In the next video, we will see how Rahul will find the trigonometric ratios of 0-degree and 90-degree. Welcome to this video. In the previous video, we calculated the trigonometric ratios of 30 degrees, 45 degrees and 60 degrees. In this video, we will calculate the trigonometric ratios of 0 degrees and 90 degrees with Rahul. We know that Rahul has a right-angle triangle LMN, where angle L is an acute angle. Suppose its value is theta. We calculate the value of sine theta, cos theta and tan theta with the help of the right angle triangle LMN. Then we get the value of sine theta as mn upon ln. The value of cos theta is lm upon ln. And the value of tan theta is mn upon lm. But if we slowly reduce the theta angle of right angle triangle LMN, then we see that the length of side mn also reduces accordingly. And at last we see that the point N comes so near to point M that the value of angle theta reaches near to 0 degrees. Then, length of side ln remains similar to the length of side LM. Then, can you tell what will be the value of sine 0 degrees, cos 0 degrees and tan 0 degrees in this condition? Well done! From the above condition, we see that the value of side MN is 0 and side LN is equal to side LM. So, with the help of equation 1, we can say that the value of trigonometric ratios of sine 0 degrees, cos 0 degrees and tan 0 degrees are 0, 1 and 0 respectively. If we talk about the value of cosec 0 degrees, then according to the above situation, we get the value undefined because dividing a number by 0 gives an undefined value. Similarly, the value of cot 0 degrees will also be undefined, and the value of sec 0 degree is equal to 1. But right now we also have to know about the trigonometric ratio of 90 degrees. So, let's go to talk about the above right angle triangle. As we reduce the value of angle theta in the above situation, similarly here we increase the angle theta until the value of angle theta is equal to 90 degrees. That is, the angle N becomes smaller as the angle theta becomes larger. That is, the length of the side LM decreases. And finally, we see that point L comes so close to point M that the angle theta is very close to 90 degrees. And at the same time, the value of angle N is also almost 0 degree, where side LN coincides side MN. In this situation, we can say that the length of side LM will be approximately 0. Therefore, to find trigonometric ratios of sine 90 degrees and cos 90 degrees are obtained 1 and 0 respectively. But the value of tan 90 degrees is undefined. Similarly, if we talk about cosec, sec and cot 90 degrees, then values of cosec and cot 90 degrees are 1 and 0 respectively. And the value of sec 90 degrees is undefined. Let us display the values of trigonometric ratios of all the acute angles by a table. Today, we discussed trigonometric ratios of 0 and 90 degrees in this video. In the next video, we will see some interesting examples based on trigonometric ratios. Welcome to this video. So far, we have discussed trigonometric ratios of some specific acute angles. Today, we will see some interesting examples based on this. Can you find the values of the following expressions? Let us discuss the first part of the example. Here, we can see that to solve this, we will need the values of sine 30 degree, cos 45 degree, tan 30 degree, cos 30 degree and tan 45 degree. So, here we get the values of all these with the help of the table of trigonometric ratios. And we know that the square of the trigonometric ratio of an angle means the square of the value of that trigonometric ratio and not the square of the angle. Therefore, here we take the value of sine squared 30 degrees equals to the square of sine 30 degrees, that is, sine square of 30 degrees equals to square of sine 30 degrees, which on solving, we get 1 by 4. Similarly, we get the values of other trigonometric ratios and solve the above equation. Therefore, the value of equation obtains 5 upon 6 multiplied by square root of 3 plus 2. To simplify the value further, we rationalize its denominator, from which we get its value 5 multiplied by 2 minus square root of 3 upon 6. Similarly, if we talk about the second part of the example, then to solve this, we get tan 60 degrees, cos 45 degree, sec 30 degrees and all other values with the help of the table. And solve it by putting in the above equation. This gives the value of the equation, that is 9. Let us see another example. If the value of sin A plus B is 1 and the value of cos A minus B is square root of 3 upon 2, where the value of A plus B is greater than 0 degree and smaller than or equal to 90 degrees and A is greater than B, then can you tell what will be the values of A and B? Let's solve it. We are given trigonometric ratio sin A plus B on the left side of the equation and 1 on the right side. So, we need to know for which value of theta the value of sin theta will be equal to 1. Suppose, for a theta whose value is greater than 0 degrees and smaller than or equal to 90 degrees, so by looking at the table, we can tell that the value of sin 90 degrees is 1. That is, here the value of theta is 90 degrees. So, we can write sin 90 degrees in place of 1 on the right side of the equation. Comparing both the sides, we get A plus B equal to 90 degrees, which is shown by equation 1. Similarly, if we talk about cos A minus B equals to square root of 3 upon 2, then with the help of the table, according to the above situation, the values of A minus B is obtained 30 degrees, which is shown by equation 2. Since we have to find the values of A and B, so we add equations 1 and 2. On solving this, the value of A is obtained as 60 degrees. So, can you tell what will be the value of B? Well done! By putting the value of A in any one of the equations, that is, in equation 1 or 2, we get the value of B as 30 degrees. So hopefully you should have understood using trigonometric ratios for specific angles. Teachers can also test students' understanding in the classroom with the help of some such examples.
Welcome to this video. Today, in this video, we will study trigonometric ratios of complementary angles. Let's have a general discussion. Can you tell what is the meaning of complementary angles? Perfect. Any two angles whose sum is equal to 90 degrees are called complementary angles, which we can understand with these examples. Let us now discuss the right-angled triangle XOY. We know that the sum of the three angles of a triangle is 180 degrees. In the triangle XOY, angle O is right angle and both the remaining angles X and Y are acute angles. So, can you look at the diagram and guess whether there are any pairs of complementary angles here? Yes. Here, angle X and angle Y form a pair of complementary angles. That is, we can say that the value of angle X plus angle Y will be 90 degrees. Assuming the measure of angle X in the triangle XOY is theta, so the measure of angle Y would be 90 degrees less theta, which we represent here by phi. So, let's find the trigonometric ratio of theta. You can also revise SOH, CAH, TOA to find the value of trigonometric ratios. Where for sin theta, we can say that its value will be equal to the ratio of the opposite side of theta and hypotenuse. Where the opposite side is OY and the hypotenuse is XY, and if we talk of cos theta, then its value will be equal to the ratio of adjacent side and hypotenuse. Here, the adjacent side is XO and the hypotenuse is XY. Similarly, find values of other trigonometric ratios, which are represented by equation 1. So now, can you find the trigonometric ratios of the angle 5 in the triangle XOY?
Well done! The value of sin 5 will be equal to the ratio of the opposite side of angle 5 and hypotenuse, where the opposite side is XO and hypotenuse is XY.
But from the figure we can see that theta and phi form a pair of complementary angles. Hence, let us substitute phi with 90 minus theta. Similarly, find values of other trigonometric ratios, which are represented by the two equations. Since we have to find the values of trigonometric ratios of complementary angles, hence, let us compare equations 1 and 2. Thus, we can see that the value of sin 90 degrees minus theta is equal to the value of cos theta. If you notice, you will see that the value of cos 90 degrees minus theta is equal to sin theta. Similarly, tan 90 degrees minus theta is equal to cot theta. Cot 90 degrees minus theta is equal to tan theta. Sec 90 degrees minus theta is equal to cosec theta. And the value of cosec 90 degrees minus theta is equal to the value of sec theta, where all values of the angle theta lie between 0 degrees to 90 degrees. In this video today, we studied trigonometric ratios of complementary angles. In the next video, we will see interesting examples based on this. Welcome to this video. We studied trigonometric ratios of complementary angles in our previous video. Today, we will see some interesting examples based on trigonometric ratios of complementary angles. Find the values of the following. Let's discuss the first part of the example. We can see that the first term given is cot 54 upon tan 36. Here 54 and 36 form a pair of complementary angles. Similarly, the second term also has a pair of complementary angles and the third term is -2. To solve this, we will use the trigonometric ratios of complementary angles. Therefore, here, in the first and second terms, we will either change the cot to tan or tan to cot. Because we know that the cot theta equals tan 90 degrees minus theta and tan theta equals cot 90 degrees minus theta. Here, we change cot theta to tan 90 minus theta as per our convenience. So, the first term of the expression cot 54 degrees is written as tan 90 degrees minus 54 degrees, which gives us cot 54 equal to tan 36 degrees. And similarly, in the second term, cot 70 degrees equals to tan 20 degrees. On solving this, we get the value of tan 36 degrees upon tan 36 degrees and tan 20 degrees upon tan 20 degrees respectively in the first and second terms, which, on further solving, gives the value of the given expression as 0. Similarly, if we talk about the second part of the example, then this expression is in sine and cos, the first two terms of which are complementary angles. And we know that sine theta equals cos 90 degrees minus theta and cos theta equals sine 90 degrees minus theta. So here, in the first term, we change sine to cos, and in the second term, change the cos to sine. After solving further, we get the value of the given equation as -2. Let's look at another example. If the sine 5 theta is equal to cos 4 theta, can you find the value of theta, where 5 theta and 4 theta are acute angles? Let's solve it. From the question, we can see that sine is on the left side and cos is on the right side. So to solve this, here we will change the cos on the right side to sine. From this equation, we can see that the value of sine 5 theta is equal to sine 90 degrees minus 4 theta. Since we have to find the value of theta, we compare the two sides and solve. That gives us the value of theta as 10 degrees. Note that it is not necessary that you change the cos 4 theta into a sine. Here, you can also solve by changing sine 5 theta into cos. In this video, we saw examples based on trigonometric ratios of complementary angles. In the next video, we will see some more interesting examples based on this. Welcome to this video. In our previous video, we saw examples based on trigonometric ratios of complementary angles. Today, in this video, we will see some more interesting examples based on this. If a plus b is equal to 90 degrees, can you prove the following equation? Let us discuss the left side of the equation. For easy understanding, we represent the first term of the square root with p and the second term with q, where the angles A and B are acute angles. This can be expressed as equation 1. Since it is given that a plus b is equal to 90 degrees, to solve these equations, we will use trigonometric ratios of complementary angles. Let us first simplify these two terms separately and find their values. Let's talk about the first term P. Here, we will substitute the angle B by 90 degrees minus A. This is how we convert tan B into cot A, cot B into tan A, and sec B into cosec A. Now, let's solve them so that we get the value of the first term as 1 plus tan square A. We will express this as equation 2. Similarly, if we talk about the second term Q, we can write it in the same way. Here, we change sin B to cos A. Solving that, we get the value Q. We can express this as equation 3. Substituting the values of P and Q thus obtained into equation 1, we get square root of 1 plus tan squared A minus 1. On solving this, the value of the left side is tan A, which is equal to the right side of the given equation. Thus, we proved this equation. So hopefully, you might have understood this example based on trigonometrics ratio of complementary angles. Teachers can also test students' understanding in class with the help of some such examples.
Welcome to this video. Today, in this video, we will study trigonometric identities. We know that an equation is called an identity when it is true for all values of the corresponding variable. But can you tell what is trigonometric identity? Well done! An identity relation related to trigonometric ratios of an angle is called trigonometric identity if it satisfies all values of the angle. Here, you are given 3 trigonometric identities. Let's discuss the first trigonometric identity of these. Let's suppose triangle LMN is a right-angled triangle. If we use Pythagoras theorem in this triangle, then we can see here we get the square of LM plus square of MN is equal to the square of LN, which is represented by equation 1. And each term of equation 1 is divided by the square of LN. Can you use trigonometric ratios in this equation along the theta angle? Well done! With the help of theta angle, we can tell that the first term on the left side is the trigonometric ratio of the square of cos theta, and the second term is the square of the sin theta, while the right side is equal to 1. So, we can say that the square of cos theta plus the square of sin theta is equal to 1, where the value of theta is greater than or equal to 0 degrees and less than or equal to 90 degrees, which is a trigonometric identity, and it is represented by equation 2. Let's see that this identity is verified between 0 degrees to a 90 degree angle. Put the value of 0 degree of theta in the left side of equation 2 for solving. Then, with the help of trigonometric ratios, we get the value of the left side as 1, which is equal to the right side of the above trigonometric identities. Similarly, if solving any value for theta on the left side of trigonometric identity, then we get a value of all these which are equal to the right side of the trigonometric identity. Therefore, we can say that this is trigonometric identity where theta has a value of 0 degrees to a 90-degree angle. Today in this video, we studied a trigonometric identity. In the next video, we will discuss two trigonometric identities. Welcome to this video. In our previous video, we discussed a trigonometric identity. Today, in this video, we will study the other two trigonometric identities. In the previous video, we divided the square of ln into each term of the equation 1 in the right-angled triangle LMN with the help of the Pythagoras theorem, giving us a trigonometric identity. What if we divide by the square of Lm instead of the square of Ln in equation 1? Let's see. The following equations are obtained by dividing the square of Lm on both sides of equation 1, where we use trigonometric ratios tan theta equals to mn upon Lm and sec theta equals to Ln upon Lm along theta, from which we get 1 plus tan square of theta equals to sec square of theta, which is a trigonometric identity where the value of theta is greater than or equal to 0 degrees and smaller than or equal to 90 degrees. Similarly, if the equation of the right triangle is divided by the square of mn, with the help of trigonometric ratios, we get Lm upon mn equals to cot theta and Ln upon mn equals to cosec theta, from which we get the value of the above equation is 1 plus square of cot theta equal to the square of cosec theta, which is a trigonometric identity where theta value is greater than 0 degrees and smaller than or equal to 90 degrees. Using these three identities, we can express each trigonometric ratio in terms of other trigonometric ratios. Let us understand this by an example. Can you prove the following identity? Let's see. Let's discuss first its left side, where we take the lowest common multiple and solve, from which we get the 2 by 1 minus square of sine theta. We know that the square of the sine theta plus the square of the cos theta is equal to 1, with the help of which here we replace the square of cos theta in place of the 1 minus square of sine theta. Can you change this value as sec theta? Well done! We know that the value of sec theta is equal to 1 upon cos theta. Therefore, in the above equation, we put the sec square theta instead of 1 upon cos square theta, which is equal to the right side of the given common identity. Thus, we proved it. Today, in this video, we studied two trigonometric identities. In the next video, we will see interesting examples based on this. Welcome to this video. Till now, we have studied three trigonometric identities. Today in this video, we will see some interesting examples based on trigonometric identities. If the value of sec theta plus tan theta is p, then can you prove that the square of p minus 1 upon the square of p plus 1 will be equal to the sine theta? Let's see. We discuss the left side of the given equation, where according to the given information, p is replaced by sec theta plus tan theta, from which we get the following equation, which we write as follows. And in this equation, using the trigonometric identity, 1 plus tan square theta equal to the sec square theta, after solving, we obtain tan theta upon sec theta. But we know that we can write tan theta as sine theta upon cos theta and sec theta as 1 upon cos theta, from which we get the left side value sine theta, which is equal to the right side of the given equation. Thus, we proved it. But is this the only way to prove this equation? No, we can solve it in other ways also. Let's see. Given that sec theta plus tan theta is equal to p, which is represented by equation 1, and we know that 1 plus tan square theta is equal to sec squared theta, which we solve by keeping the square of sec theta minus the square of tan theta as 1. And from equation, we know that sec theta plus tan theta is equal to p, which is substituted here. We get sec theta minus tan theta is equal to 1 by p, which is represented by equation 2. Now, if we add equations 1 and 2, we get sec theta is equal to p square plus 1 upon 2p, which we can also write in this way, since we know that cos theta equals to 1 upon sec theta. Similarly, if we subtract equation 2 from equation 1, we get tan theta is equal to p square minus 1 upon 2p, where we change tan theta into sine theta upon cos theta. After solving, put the value of cos theta. And see that on solving, we get the same value of sine theta that we were given in the question. Thus, we proved that both sides are equal. At last, a question is given to you to solve. So hopefully, you must have understood this example based on trigonometric identities. Teachers can also test the understanding of students in the classroom with the help of some such examples. Welcome to this video. Today, in this video, we will discuss the interesting problems of trigonometry. If A is equal to 5 degrees, then tell whether the given equation is right or wrong. If this equation is right, then the value of left side and right side should be equal. If we talk about the left side, then here we have to calculate the value of sine of the square of angle A. Here A is equal to 5 degrees. So, the square of A will be equal to 25. So the value of left side should be equal to the value of sine 25 degrees. With this, the right side is equal to the square of sine A, or in other words, to the square of the value of sine A, where by putting A equals to 5 degrees, we get the value of square of sine 5 degrees, which shows that the right side is not equal to the left side. Hence, the given equation is wrong. Let us see one more example. Choose the correct alternative of the following expression. Pause the video to solve the question and then match your answer. If you have chosen the first option, then it is a good try, but this is the wrong answer. Here, we are given tan 60 degrees in numerator and 2 in denominator. While solving this question, some children divide angle 60 by 2 and write the value of tan 30 degrees, which is the wrong answer. Here, option 2 is the right answer. Let's discuss this. We can also write the given expression in this way. We know that the value of tan 60 degrees is the square root of 3. By substituting this, the value of the given expression is found to be square root of 3 by 2, which is correct. Keep in mind that angles of trigonometric ratios can be divided only when the condition is like this. Teachers can also test the understanding of students in the classroom with the help of some such examples. Today, we discussed interesting problems of trigonometry.